Hello, we are discussing about sampling gates under PDC Pulse and Digital Circuits course. Sampling gates are also called as linear gates, transmission gates as well as selection circuits. The main function of sampling gate is output of sampling gate must be either exactly reproduction of input signal or at least output must be proportional to input signal during transmission period, else output must be 0. That is V0. If V0 is output signal, Vin is going to be input signal, then V0 must be equal to Vs, or at least V0 must be proportional to Vs during transmission period, that is during a selected time interval, and except that time interval, in all other cases output must be 0. So except that time period is called as non-transmission period, during that selected time period is called as transmission period. So sampling gate will have two periods, one is transmission period, the other is non-transmission period. During transmission period, output must be exactly either equal to Vs or at least it has to be proportional to Vs. And during non-transmission period, output must be 0. How to select this time period? That is, how to select transmission period? The transmission period is selected with the help of control signal. Control signal, or it is also called as selection signal, indicated with Vc. Vc is always a rectangular waveform which will be having two levels, V1 and V2. Depending on the sampling gate, it may be bidirectional or it may be unidirectional or bidirectional using transmission transistors. In that one you may go for the emitter couple also. So depending on the different circuits, if the control signal is at one place, is at one level, then the sampling gate may be acting as a closed switch, then the output is exactly equal to Vs or at least proportional to Vs. If the control signal is at other level, then the output is independent of input. So control signal is used to select the transmission period. So during this path, say this is Tg or gate width, gate width or transmission period, width of transmission period. So let us assume at V1 the sampling gate is closed and at V2 sampling gate is open, so that during this path, during this period output is equal to input, so we are calling it as transmission period, so that in indicating with Tg. So we will see what are the different types of sampling gates are available. There are two different types. One is unidirectional sampling gates. The other is bidirectional sampling gates. Unidirectional sampling gates, as the name implies, it can either pass only one type of signals, either positive going signals or negative going signals. Positive going signals is nothing but which will be having a signal all positive values, a signal consisting of all positive values, and negative going signal means the signal is going to be having only negative values. It doesn't mean positive going signal is nothing but it is going from -10 to -2. That is also looks like it is increasing manner. So we are not going with in that way. It either passes, it can either passes, transmits only positive signals, or negative signals, but not both. Here bidirectional is nothing but it can pass both the signals, as the name implies. So always unidirectional sampling gates are implemented with diodes. By using diodes we can implement unidirectional sampling gates, whereas bidirectional sampling gates can be implemented either using diodes as well as transistors, BJTs, bipolar junction transistors. So first we will discuss the basic principle of logic gates with the help of a switch. Later we will discuss about the unidirectional diode gates, and how to implement it for the more number of inputs, what are the advantages and disadvantages, and how to overcome the disadvantages. Later we will discuss about the bidirectional sampling gates, first by using BJTs, what are the disadvantages, how to overcome, then we will go for the diodes. diode bidirectional gates, and after that one 4 diode gates, 4 diode sampling gates, 6 diode sampling gates also we'll discuss. Later on, the last part is nothing but application of sampling gates. In that one we are going to discuss two parts. One is chopping amplifier, the other is sampling scope. Okay. So let us assume this is going to be a switch, okay, which is operating with a gating signal. Now the switch is in series with outputs, whereas this case is switch is in parallel with output. Okay, both the switches are going to be operated by gating signals, and just now we have seen gating signal is a rectangular pulse which will be having two levels. Okay, so when switch is closed, for this case, then we can say that one V0 is equal to Vs, which we call is transmission period. Whereas when switch is open, V0 is independent of input and no current flows through this resistor. That means V0 is equal to 0. So this is non-transmission period. And you can also place the switch which is controlled with a gating signal that can also be connected in parallel with output. When it is in parallel with output, the operation is exactly opposite of previous one. Okay. So when S is closed, the entire current is taken by this switch, and whenever switch is closed, V0 is equal to 0. Switch is closed is nothing but acting as short circuit. For short circuit, voltage across short circuit is 0 volts. So whenever switch is closed, V0 is equal to acting as short circuit. That means 0 volts is present at the outputs. And when S is open, so V0 is 0. This is called as non-transmission period. And when S is open, by that time V0 is equal to Vs, as the switch is acting as open circuit. So this is called as transmission period. Okay. How much time the switch has to be closed or how much time the switch is going to be open, that is totally decided or controlled with the help of gating signal. Okay. And generally the switches are going to be active elements. They can be replaced either with diodes or they can be either replaced with BJTs, FETs, okay, etc. active elements. So now we'll see the basic difference between a logic gate and a sampling gate. Okay. Generally, whenever we say gate, by the time in our mind, first it comes is logic gate. But what we are going to discuss is sampling gate. What is the difference between logic gate and sampling gate? Okay, logic gate versus sampling gate. In logic gate is totally used in the digital circuits. Okay, it is always used in the digital circuits. So the inputs are going to be digital inputs as well as outputs. So that means inputs and outputs, either it may be having a pulses or it may be having some voltage levels. Only two voltage levels are going to be possible, either high level or low level. That is a range of voltage which specifies high voltage, a range of voltage which specifies low voltage. Okay, and here output is not exact replica of input. And always output is going to be function of inputs, but output is only a two-level signal, either it may be high or low. It doesn't follow the inputs, but based on some logic operation, digital operation, either AND, OR, NOR, XOR, like this, the output related with inputs. Okay, so it is mainly used with digitals, and whereas sampling gate is mainly used for the analog. Okay, analog circuits and analog inputs and outputs. Okay, so during transmission period, we know that one output is exactly equal to Vs or at least proportional to Vs. That means the shape of the input signal is preserved at the output side. So V0 and Vs are proportional or at most equal. That means shape of input signal. Shape of input is appeared at output. So the shape can be either sinusoidal or any random signal. It may be square waveform, rectangular waveform, triangular waveform, or any waveform irrespective of its shape. It may be a random noise signal also that will appear exactly at the output, how it is looks like at the input side. So this is the shape is going to be preserved, which implies nothing but analog, and digital is going to be only consisting of two levels. So this is a basic difference. Okay, here inputs and outputs can be any wave shape, and whereas in case of logic gates, inputs and outputs must be of only two levels, and in case of logic gate, output is only at two levels. Okay, whereas in case output is exactly equal to inputs. Now we will see a unidirectional diode sampling gate. This is a circuit diagram for a unidirectional diode sampling gate. Okay, look at this one. This is the diode D, and it is output signal we are taking across RL, input signal Vs applying towards capacitor, and this is control signal Vc. Vc is always control or gating signal that is having two levels, that we are saying it as minus V1 and minus V2. That means both are going to be negative signals, or at most it may be equal to 0. We can vary this V1, what happens that also we'll see. Okay, and as the diode is going to be shown from this is P side and it is N side. We know that one diode can be either biased in forward bias or reverse bias. In forward bias, ideal diode acting as short circuit. In reverse bias, ideal diode act as open circuit. So let the diode is ideal. If it is ideal diode, okay, when the diode is forward biased, then this node and this node are going to be shorted. That means output node and input node are going to be connected whenever it is forward bias. So this will be forward bias only when P side is going to be more positive than N side. That means diode forward bias. A diode is said to be in forward bias only when P side of the voltage is going to be more positive than N side of the voltage of the diode. So that means it is only possible to transmit positive going signals. Since the N side is connecting at 0 volts, okay, N side is connecting at 0 volts, so always this side voltage is going to be of positive. If you are going to apply a positive voltage effectively across P side, then that will be transmitted towards output. Otherwise, the diode is going to be under reverse bias. So this unidirectional gate passes, that is transmits only positive signals. If you are reversing the diode, then it can transmit only negative signals. So now we are discussing only positive signals. Now look at this one. The diode P side is going to be effectively connecting with two signals. One is source signal, that is input signal, and the other is control signal. Control signal, this is transmission TG. Transmission width is this much. Okay, transmission period. During this period we are applying input signal, and before that one also you can apply the input signal, after that one also you can apply the input signal. It doesn't matter, but only during transmission period only the input transmits towards output side. During transmission period also, during over this side and over this part, we can say input is 0, Vs is equal to 0, and only over here Vs is not equal to 0. That is during this transmission period, out of entire transmission period, only for a small duration only we are applying input signal, and other durations you are not applying any input signal. Understand this fact, it is very important. Okay, and whenever you are applying two signals, okay, then this point is going to be loaded with two signals, input and control signal, and effectively voltage across the P side of the diode is going to be superposition of both the signals. That means Vs plus Vc. Okay, and for a diode to be forward biased, we must know that one voltage on P side should be greater than N side. So diode is forward bias. Diode is forward bias. For that one, to become this diode is forward bias, control voltage should be at minus V1. So Vs plus V1 we will go with, and V1 we can think it as negative, so that it is going to be greater than N. For that one, you will use some positive voltage, so we can say it as, if you want to, then Vs plus V1 should be greater than N, so the diode is forward bias and act as short circuit. So V0 is equal to Vs. This is only possible when V1 is equal to 0. Otherwise, output will be equal to Vs plus V1. Output will be equal to Vs plus V1. When V1 is equal to 0, V0 is equal to Vs plus V1. That means V0 is equal to Vs. Otherwise, if V1 is not equal to 0, V0 is function of both the signals. So ideal value of V1, ideal value of V1 is equal to 0. If V1 is equal to 0, then entire signal is going to be transmitted to output. Otherwise, a portion of signal may be dropped if it is negative. Otherwise, you may get extra signal if the value of V1 is positive. Those examples you will see later. Okay. So first of all, transmission period. During transmission period, diode is forward biased. By that time, whenever it is forward biased, it is acting as short circuit. That means output node and this effective node is going to be both are same. So you can say that one output is equal to voltage on P side, which is Vs plus Vc, and diode is forward biased. During control signal is at V1, so we are going with V1. Okay, so Vs plus V1 is equal to V0, and whenever V1 is equal to 0, V0 is exactly equal to Vs. So ideal value of V1 is equal to 0. Okay, and if so that V1 can be any other values also, that we will see it later. Now during diode reverse bias, second case. Okay, this is case 1, transmission period, and case 2, non-transmission period. During non-transmission period, we expect V0 is equal to 0. That means diode has to be reverse bias. Since it is reverse bias, it acts as open circuit. Okay, so now there will be no connection between the output and inputs. We can say that one diode is reverse bias only when voltage on P side is going to be less than voltage on N side. Voltage on N side is connecting with ground, 0 volts. Voltage on P side is effectively Vs plus Vc. And now Vc during non-transmission period, Vc is going to be at V2. There the voltage Vs plus V2 should be lesser than 0. That means magnitude of V2 should be very large compared to Vs. Even if you are going with a large positive signal also, during non-transmission period, the diode should not be forward bias. Okay, so the condition for the control signal is V2 has to be a very large negative value, such that even though you are going with a large positive voltage also, the effective voltage at P side has to be negative, so that diode must be in reverse bias. Then only you will get output is equal to 0. That can be treated as non-transmission period. So condition for this one, magnitude of V2 should be greater than Vs, so that effective value is always negative at P side of the diode during non-transmission period. These are the two conditions. Okay, now we will see what happens if you are applying different values of V1. We always assume V2 is at large negative value. That doesn't matter. Only V1, if V1 is going to be changes, how the output will get changed, that we will see now. So let us assume input signal Vs is from 0 to 10 volts, that too only during this period, that is 0, 1, 2, 3. For example, this is 0 to 3 is a transmission period. Okay, So during 0 to 3 is the transmission period, but the input signal is applied between only 1 and 2. Remember that one. So if you are applying this signal, and first case, we assume that first case, this is case A, where the input signal is constant, that is having 10 volts magnitude during 1 to 2. And now we are going with V1 is equal to, V2 is always constant, V2 is always at minus 20 volts, and now assume that one V1 is at minus 10 volts, first case. Whenever V1 is at minus 10 volts, if the diode is under reverse bias during non-transmission path, output will be 0. During non-transmission path, output will be 0. During non-transmission path, that means up to this point. During non-transmission path, diode is reverse bias and output is 0. And even during transmission path, by that time you are applying minus 10 volts, minus 10 volts plus 10 volts, the voltage across this point P side is going to be 0, so you don't get any outputs, even though you are going with a input signal also, but output will be at 0 only. So no transmission is taking place. That's why V1 should not be a negative value. That too, V1 we have taken it as a large negative value. It should not be in this way. Okay, so V1 minus 10 volts is going to be taking entire 10 volts of input signal, so that the effective voltage is 0 volts. It is not even going into positive side, so that no signal is going to be transmitting, even though during transmission period. Okay. This diagram is going to be showing superimposition, that is input signal appearing on above the control signal. So this is input signal and it is above that one control signal is adding between 0, 1, 2, 3. Now second case, let us assume V1 is a little bit small negative voltage. Now V1 is 5 volts. By that time, okay, during non-transmission period, this is non-transmission period, where the non-transmission period diode is reverse bias. Okay, because during non-transmission period V2 is at minus 20 volts, even though you are going with plus 10 volts, if it is appearing also, okay, so minus 20 plus 10, it will become minus only, so that during non-transmission period output will be 0. And after that, during transmission period, the signal is not appearing from 1 to 2 and 0 to 1 and 2 to 3. Signal is not appearing, so that even though the signal is not appearing, what you are going to get is 0 volts only, because during this path also diode is reverse bias. Diode is reverse bias. Whenever diode is reverse bias, output is independent of input, so you will get 0 volts only. That means you will get these values. And next, during 1 to 2, the signal is applied of 10 volts magnitude, but already V1 is at minus 5 volts, minus 5 plus 10, that will be giving only plus 5 volts effectively at this point. The effective voltage is always at Vc plus Vs, that means V1 plus Vs during transmission path. V1 is at minus 5 volts and Vs is at 10 volts, minus 5 plus 10. So finally you are going to get it as V0 is equal to V1 plus Vs, for this one minus 10 plus plus 10 minus 5. So this will be equal to plus 5 volts. You will get only plus 5 volts magnitude. That is a lack of signal or suppressed signal is appeared. Okay, attenuated signal. So this is also not the right case. Now we are going for the third case. Let us assume this case V1 is exactly equal to 0. V1 is exactly equal to 0 volts. So now the V1 is at 0 volts. By that time, during transmission period, okay, when the signal is not appeared, then the diode is under reverse bias, you will get 0 volts. Okay, 0 volts, that means 0 to 1 as well as 2 to 3. And during transmission path between 1 and 2, there is a signal of magnitude 10 volts is applied, that 10 volts will be added to 0 because V0 is equal to V1 plus Vs during transmission path, during transmission period. So 0 plus 10 is 10. So entire signal now V0 is equal to Vs in this case. That is ideal case where V1 is equal to taken as 0. If V1 is equal to 0, whatever the small change in the V input towards positive, that will appear at the output side. Okay. Otherwise, if you are going with, now say this is applying with plus 5 volts, instead of 0 we are going with plus 5 volts, some positive voltage. So during transmission path, diode is forward bias, effective voltage across this one is always, even though the signal is not applied, but V1 is at plus 5, so output will be at plus 5. Output will be at plus 5, and when the signal is applied, that signal is superimposed on the output signal, that is control signal. So 10 plus 5, it will be going into 15. And whenever the signal is not applied, again it is comes back to 5 volts. And during non-transmission period, it will be 0. This is the output signal. Okay, during non-transmission period output is 0, and during transmission period if the signal is 0, then the output is at plus 5 volts. If the signal is present, output will be at plus 15 volts. Okay, so this is a signal where the difference is going to be treated as pedestal. This is called as pedestal. Now we will define what is meant by pedestal. So look at this one. This point is output during non-transmission stage, non-transmission period, and this one output during transmission period with 0 input signal, that is Vs is equal to 0, and this is output during transmission period with Vs, that is Vs not equal to 0. Okay, so always pedestal is going to be the difference between the outputs when the output is under non-transmission period and the output during transmission period with Vs is equal to 0. Okay, we always expect output should be 0 or output should be same, even if it is in non-transmission period or if the signal is going to be not applied during transmission. Even though it is transmission period, but if you are not applying any input signal, what do you expect? You expect the 0 outputs, that is same output during non-transmission period. If there is a difference find, then the difference is going to be called as pedestal. That pedestal can be either positive or it can be negative also. So pedestal is the difference between the outputs during non-transmission period and during transmission period with Vs is equal to 0. That is the definition of pedestal. Remember this one. Okay. Again I am saying pedestal is the difference between the outputs during non-transmission period and during transmission period with 0 input applied. If there is no difference between these two cases, then the pedestal is 0. If there is a difference, the difference can be either positive or negative also. Now we are seeing positive pedestal, pedestal of positive nature. Later we can go with negative pedestal also during bidirectional sampling gates using BJTs. Okay. Now we can also extend it to the more number of input signals. Previously we are going with only one input signal where the source is 1 Vs, that is connected to Vc, that is connected to a capacitor and diode. So only RL, diode, capacitor and Vc. But now it can be extended to more number of inputs. Here we have seen with only 2 inputs. So Vs1, Vs2 are 2 input signals. They are coupled to the diode P side using capacitors, and the control signal is going to be applied through separate resistors R and R. Okay, this is C and it is C. This is diode 1 and it is diode 2. So since you are applying the same control signal is of rectangular nature, so it may be at V2 and V1 levels. When Vc is at V1 level, that is transmission period. Vc is at V1, which is called as transmission period. By that time diode 1 and diode 2 both are going to be forward bias. Now V0 is the effective voltage, which is nothing but at this point where it is affected by Vs1 as well as Vs2. So V0 is equal to Vs1 plus Vs2 plus Vc for ideal value. Okay, for V1, let V1 is equal to 0, that is ideal value. Then V0 is equal to Vs1 plus Vs2. Okay, output is now proportional to both the input signals, but whenever you are adding both the input signals, it will be some non-linear signal which is not either belongs to Vs1 or not belongs to Vs2. So the limitation of this one, the limitation is nothing but at any instant of time, during transmission period, only one input should be applied. Either Vs1 should be applied or Vs2 should be applied, but not both. If you are applying both at the same time, both the signals are going to be applied at the output side, the output is going to be distorted and it is neither related to Vs1 nor related to Vs2. So that this is a limitation, very important, which is the disadvantage of this circuit. Okay, so during transmission period, V0 is equal to Vs1 plus Vs2 when the V1 level is at 0 volts. But you must apply only one signal at a time. Okay, and second case, when Vc is at V2, by that time it is non-transmission period. During non-transmission period, both the diodes, diode 1 and diode 2 are reverse bias, so that they act as open circuits. When they are open circuit, V0 is independent of Vs1 and Vs2, so output will be 0 volts. So output will be 0 volts, that means no transmission is taking place, none of the input signal is present at the output side, and during transmission period output is superimposition of Vs1 and Vs2 when V1 is at 0. That's why the limitation is we must apply only one input signal, even though you are going with more than two also, whether it is 3, 4, 20, 40. Okay, at any instant of time only one input signal should be applied simultaneously, so that signal will appear at the output side and output is exactly reproduction of input signal. This is the limitation. So we can also extend the unidirectional diode gates for more than one input signal. This is an example corresponding to 2 inputs. This can also extend it to 2, 3, 4, 5, 10 also. Okay. Next we will see the advantages and disadvantages of sampling gates. First we will go for the advantages. Okay, so first advantage is simple circuits, because it consisting of only 3 elements for a unidirectional sampling gate which consisting of only single input. So it's a simple circuit which will be consisting of Vs, a capacitor, diode and 2 resistors. It's a very simple circuit. And second one, the time delay between output and input is very small. Okay, time delay between output and input is very small, because whenever during the transmission period, if the input is applied, capacitor doesn't allow instantaneous changes in the input signal, directly it will appear at the output side. So the delay is going to be very small, as capacitor doesn't react for the instantaneous changes in the inputs. So voltage across capacitor doesn't change. That means whatever the changes you are getting at Vs1, that will be affected on V0 directly at that instant itself. So the delay between output and input during the transmission path is almost zero or very very small practically. And third advantage, during non-transmission path or during non-transmission period, no current is drawn in the circuits. No current drawn in the circuit. That means no current is drawn means no power dissipation. Power dissipation is zero during non-transmission period. Okay, that is under quiescent conditions, whenever the input signal is not applied, as well as during non-transmission period, the diodes are under reverse bias or almost it may be at the verge of forward bias, but no current flows, so that power dissipation in the circuit is zero. That is the advantage. Fourth one, it can be extended to more number of inputs also. It can be extended to more number of inputs. Just now we have seen with 2 inputs. Okay, these are the advantages. Now we will turn into the disadvantages. Okay, this is a circuit diagram related to the 2 input unidirectional diode sampling gate. Now we will see about the disadvantages. First disadvantage, always there is an interaction between input signal source as well as control voltage source, because control voltage source as well as input signals are going to be applied at same point, so that always there is an interaction between input and control signals. Always there is an interaction between control signal and source signal. Okay, so the output is going to be affected, because output is function of both Vs and Vc during the transmission period. As long as V1 is at 0, output is exactly equal to Vs, but V1 is going to be, if it is positive or negative, output is going to be gets distorted. Okay, so second disadvantage, even though we say that one, the delay between output and input is going to be very very small, because output is coupled to the P side of the diode through a capacitor. Capacitor is going to be doesn't change instantaneously, so that the changes in the input are directly appears at the input side of P side of the diode, which is nothing but output itself during transmission period, as the diode is forward bias. But whenever you are applying control signal, the control signal is going to be reaches. Okay, as you are applying control signal, we assume that one it reaches -20 to 0 instantaneously like this, but it never happens like this, because it is RC circuit. For that one you are applying a control input. As you are applying control input towards a RC circuit, which is going to be the voltage across P side, so voltage across P side changes exponentially with respect to time constant of RC, so it takes some amount of time to reach towards final value of 0. If the input signal is appeared during this path, then the output is going to be gets distorted, so you may get like this. Okay, and not only during charging, as well as discharging period also, whenever it has discharged from -0 to -20, this discharging period also takes with respect to time constant, again it is RC itself. Okay, and during that path also, if the input signal is present, it has not reached -20 volts, so you may get some outputs. So these are the disadvantages. So you must apply the input signal when the control signal is reached the steady state value during transmission period. That is, after reaching 0 volts only you must apply the input signal. If you are applying before, then there is a distortion in the output signal. And even during non-transmission period also, if it has not reached -20 volts properly, then the signal, if it is present, it will also appear somewhat at the output side. This is a disadvantage. Okay, so because of this slow rise time of control input, the output may get distorted. because of slow rise time. It is not instantaneous. Slow rise time of control inputs. Output may get distorted. Output may get distorted if the input signal is applied before reaching the steady state. So this is second disadvantage. And third disadvantage, as the number of inputs are going to be increases, loading on the control input becomes excessively heavy. Okay. This is as number of inputs are going to be increases, then loading on control inputs increases. Okay, it becomes very heavy. We will see what is mean by this one. So there are here, this is the example for the unidirectional diode gate using two inputs, VS1 and VS2, and only one control signal is going to be used. If we are going for the 3 input also, only one control signal which is going to be applied to all the 3 diodes. If you are going for a 10 input also, there will be 10 diodes. All the diodes are given with only one control input. So generally speaking, at every node there will be a parasitic capacitor is going to be present, okay, which is going to be storing the voltage given to that point. So if VC is going to be applied for both the diodes simultaneously, then there is a charge sharing. So these two capacitors are going to be sharing the charge given by this voltage. Finally you are going to get it as VC by 2 over here, VC by 2 over here. During transmission period it will be V1. So the voltage at this point will be V1 by 2 and voltage at this point is V1 by 2. Okay. So during transmission period, sometimes if the number of inputs are going to be increases, the voltage present on this one may not become forward bias the diode, may not be enough to make the diode forward bias. So that is the disadvantage. As the number of inputs increases, the same voltage is going to be shared by that many number of diodes. So voltage across the diodes on P side is going to be gets reduces, which may not be forward bias those corresponding diodes. So that is the limitation of this circuit. Okay. So we should get a circuit where the output is, where the control signal is independent of number of inputs. So how to get that one, that we will see it later. Fourth disadvantage. Here the output is sensitive to control input voltage V1, that is upper level of VC. Output is sensitive to V1. As V1 changes, V0 is also changes, since V0 is equal to Vs plus V1. If V1 is 0, output is exactly equal to Vs. Otherwise what happens? V0 is going to be addition of Vs and V1. So output is sensitive to V1. We must get a circuit where the output is independent of V1. Okay. And the last one, already we have seen this limitation. Only one input should be applied simultaneously. Only one input should be applied at any point of time. Okay. No two or more inputs should be applied simultaneously. Otherwise output will be gets distorted. Okay. So in case of multi-input unidirectional gates, at any point of time, at any instant of time, okay, only one input should be active, so that output will be equal to that input. Then there is no distortion between output and input. If more than one input signal is active during transmission period, then output is going to be gets distorted. It is neither equal to the first signal or the second signal or any active signal. Remember that one. So this is unavoidable, okay, for the circuits. Now we will see how to avoid the disadvantages one by one. Okay. So look at this circuit where this is going to be a unidirectional diode gate with two inputs, but there is no loading on the control input. Okay. So because the control signal is applied to only one diode, so directly whatever the signal you are applying, that will be taken by this one. There is no discharge, that is there is no less voltage to be accumulated across diode P side. So that means loading effect is reduced. Loading effect is reduced because control input is directly applied to the diode. So how you are applying the two inputs? Check this one, Vs1 and Vs2. Always you will get Vs1 plus Vs2 over here. Okay, but the summation of Vs1 plus Vs2 should be reaching the output or not, that is decided by this diode. When the diode is forward bias, then Vs1 plus Vs2 will reach V0, otherwise output is 0. So whether the diode is forward bias or reverse bias, which is decided by the control input. So based on the control input values, whether it is in transmission period or non-transmission period, based on that one, the Vs1 plus Vs2 may appear at the output or may not appear at the output. But for this one also, the limitation is only one input signal should be active at any instant of time during transmission path. But the disadvantage of loading on control input is avoided. Okay, so this is not loading the control signal. Now look at this one. This is a gate whose response is not sensitive to upper level of control voltage. So it is not sensitive to V1. Okay, whose response, that is output V0. Now V0 is independent of V1. That means you may get V0 is equal to Vs itself, not plus V1. How you are going to get this one? This is control signal Vc and it is Vs. Let us assume we are discussing about the only transmission period, so that Vc is at V1. Okay, and otherwise it may be at both levels, Vc and V1 and V2. We will discuss one by one. So case 1, when Vc is at V2, V2 means a large negative value, remember that one. A large negative value you are applying such that it is going to be dominating along with this VCC voltage across this one. This is plus VCC. Okay, remember this one, it is plus VCC. So a large negative voltage along with this plus VCC, you are going to get the value over here as negative. So voltage of n side of voltage on n side of diode D1 is equal to some positive voltage here, some negative voltage, some negative voltage. So you will get some negative voltage over here. Whenever Vc is at V2, V2 is a large negative voltage, even though it is of plus VCC, the point over here is going to be large negative value. That large negative value makes D1 forward bias. Whenever D1 forward bias, at that time P and N are going to be acting as short circuit, so that the negative voltage will appear over here. So voltage on P side of diode D0 is going to be at negative voltage. That makes D0 diode reverse bias, so that V0 is 0 volts independent of input signal. That's why it is called as non-transmission period. Non-transmission period results whenever control voltage is at V2. Okay, understand the operation. V2 is at large negative voltage. That large negative voltage is greater than even VCC, so that effective voltage at this point is always negative, and negative voltage you are applying towards n side of the diode, so that this diode D1 will comes into forward bias. Whenever it comes into forward bias, it acts as short circuit. As it is short circuit, voltage on P side and N side must be same. So as N side is at negative voltage, that negative voltage will appear over here. You may think Vs may be positive voltage. That positive also, if it is added, the effective voltage at P side will be negative only. That is the condition. Okay. So voltage on P side of the diode D0 is always negative during non-transmission period, so that D0 is always reverse bias. So output will be having 0 volts. Okay. Now we will see the second case. Now we will see the second case when Vc is at Vc control voltage is at V1, that is it may be either 0 volts ideal value. So whenever you are applying 0 volts, by that time this is plus Vcc, that plus Vcc is applied to N side of diode 1. So voltage on N side of diode 1 is going to be now positive voltage. So diode 1 is reverse bias. When diode 1 is reverse bias, okay, so it is acting as open circuit. So simply it is going to be removing this diode. You are removing it, and then Vs is directly connecting to P side of the diode. If it is a positive signal, then definitely that makes the diode into forward bias. For all positive values of Vs, diode D0 is forward bias and V0 is equal to Vs. This is called as transmission period. So now during transmission period, the diode D1 is acting as open circuit, so that it is independent of V1. Now the V0 is independent of V1, because V1 is not at all connected towards outputs during the transmission period. This is how we can reduce the disadvantages. Okay. So we'll see one more circuit. Can you identify the relationship between output and the control voltage? Okay. For what control voltage, output will be equal to Vs. So there are three control signals are used: Vc1, Vc2 and Vc3. This is again unidirectional gate which passes only positive signals because of the diode shown. Okay, by looking at the diode D0, we can say that one it is always positive going unidirectional gate. Okay. And for what value of control signals Vc1, Vc2, Vc3, V0 will be equal to Vs, otherwise V0 will be equal to 0. According to function of sampling gate, we know that one output must be exact reproduction of input, or at most it must be proportional to input signal during transmission period, that is when the D0 is forward bias, and output must be 0 when the D0 is reverse bias, that is non-transmission period. So we can go for the first case. Okay, let us assume all the diodes D1, D2, D3 are going to be reverse bias. Then they are acting as open circuit. When they are acting as open circuit, then point A is independent of control signals. If DA, DB and DC, DA, DB, DC, D1, D2, D3. If D1, D2 and D3 are reverse bias, then voltage at point A is independent of control voltage Vc1, Vc2 and Vc3. Okay, so then we can say that one directly this plus Vcc is going to be sufficient enough to make the diode D0 forward bias. So diode D0 is forward bias and V0 is proportional to Vs. This is called as transmission period. So only V0 is equal to Vs only when D1, D2, D3 are going to be reverse biased. By that time, voltage at P side of D0, that is point A, node A, is independent of control voltages. Output is directly proportional to input signal as the diode is forward biased with the help of VCC. Okay, so we may assume that one, since the diode is forward biased, a current flows, so total VCC is going to be appearing across R itself. Okay, so effectively the voltage results because of VCC is 0 volts at this point. So whatever the signal you are applying, that will be applied directly towards outputs. Then V0 is equal to Vs also we can say. Otherwise V0 is proportional to Vs. Okay. Now we'll discuss about the second case. Okay. In the first case itself, how to make this diode 1, diode 2, diode 3 reverse bias. For that one you must apply some positive voltages. So if you apply positive voltage, all these things are going to be possible whenever VC1, VC2 and VC3 are going to be at V1. Okay, the condition for this is a condition for transmission period. So transmission takes place only when all the control signals are at upper level. Okay, and second case we are going with, if any one of the diode, if either D1 or D2 or D3 or any combination of diodes, any combination of D1, D2, D3, if D1 or D2 or D3 or any combination, that is D1, D2, D1, D3, D2, D3 or all three are going to be forward bias, okay, then the voltage at VA is going to be negative voltage effectively. So since it is acting as short circuit during that path, whenever it is short circuit, the voltage across this node is going to be negative. So VA will become negative, that makes D0 reverse bias. So V0 is equal to 0. So V0 is equal to 0 means non-transmission period. So condition for this one, condition for non-transmission period is the voltage VC1, either VC1 or VC2 or VC3 should be at V2. Okay, at least one of control signal should be at V2. Then that corresponding diode will be under forward bias, that makes the voltage across P side of the D0, that is node A voltage, will become negative, that makes diode D0 for reverse bias, so that V0 will be 0. So that is non-transmission period. So you can think that when transmission takes place only when all the inputs, all the control signals are at V1 level. So it's going to be looks like 3 input AND gates. Whenever the inputs control signals are going to be at all the control signals are at high level, that is upper level V1, then only transmission takes place. Okay, analog 3 input AND gates. You can also think in that way. Thank you.